Hi, welcome to MVP Days, and actually welcome to Linux Lift and Shift to Azure. My name is Robert Corradini, and today we're actually going to talk about really how to identify and plan those migration of those applications and servers, especially in the Linux, what we're talking about, to the Microsoft Cloud. So let me explain who we are. Liquidware is actually one of the sponsors of this month's MVP Days, and who I am. We were founded in 2009 by virtualization industrial leaders. We are headquartered in Chicago, but we do have a global presence. We are a privately held company. We do have some great key strategic alliances with Microsoft, Amazon, Citrix, Nutanix, and VMware. And we do have an award-winning suite of solutions, which I'll talk about in a moment. And we do have a global network of channel partners. And again, my name is Robert Corradini. I'm the Director of Strategic Alliances here at Liquidware. I'm also a 3-time MVP in Cloud and Data Center. And as I had mentioned before, we have numerous awards between Gartner and Citrix, etc. And our mission in the UEM space, the User Environment Management space, is to really be the preeminent third-party provider of software that really reduces the cost and complexity of desktop environments across really all platforms and devices. We also enable desktop virtualization to be used cost-effectively for more and diverse types of users, thus increasing that ROI, lowering that TCO for these types of deployments. And as I'd mentioned before, I'm sure you recognize some of our customers. We're an enterprise-ready company. What we do essentially is adaptive workspace management. And how we do that is first of all, we deliver with user environment management. Our Profile Unity product delivers superior full-featured user environment management. And then coupled with our FlexApp application, which is application layering, it really delivers advanced application layering integrated with user environment management and really makes that easy to manage. And then we have monitoring and diagnostics that really kind of completes that puzzle, which our Stratosphere UX product offers a sophisticated user experience monitoring and diagnostics from onboarding to everyday user experience metrics. So, why are we here today? Now I'm done with the housekeeping. We're talking about Linux and lift and shift. And the process of identifying applications suitable for lift and shift is essentially a multi-stage filtering process. Really, your team has to look at each application and service you're considering as a candidate for moving forward to the cloud, and then generate a list of these hosting resources used by applications, including both physical and virtual devices. At the end of this process, you should have a list of candidate applications you can successfully migrate to Azure hosting with a minimal re-engineering investment. At this point, you can begin to focus on how application and service workloads can take advantage of cloud-specific deployment models. So, step 1, capturing that application inventory. So first of all, we have operating systems and versions and patch levels. So for any servers used by a candidate application or service, it's really important to note the platform, operating system, version, and what patches have been applied to that specific distro. Application frameworks, really important, and third-party libraries. For any software that is used as part of your candidate application or service, you need to identify any application frameworks that are used by them, like .NET or Java JDK. Also, really, you got to please make note that framework version that's in use. Simply take note of any third-party code or libraries used along with currently installed version. Next up is device and infrastructure integration. You need to identify any network switches, routers, specialized load balancers, firewalls, or any devices required to run that application or service. Note any specialized appliances or other hosting hardware, as well as any dedicated storage devices. Operations integrations, another very important aspect. List really any automated agents or any other processes providing monitoring, security, and notification capabilities for your applications, services, or even network infrastructure. If there are manual processes involved in maintaining your system, note those as well. Again, very, very important things. What's the available SLA? for each resource, documented the expected SLA and uptime requirements. Usage and utilization metrics, really important. And those are, for example, you could use a product like ours, Stratosphere UX, where you could actually go and get utilization and usage matrix to understand those workloads on that Linux distribution. You really need to collect any usage and network hardware utilization information for your server resources, including information of both nominal and peak workloads. Very important. And note any predictable patterns of usage, such as high traffic during a particular date or a specific times of the day. Last but not least, on step 1 is backup and archive, high availability and disaster recovery. You really want to document how those resources are backed up and note archiving and retention policies. You want to note infrastructure that's in place to meet the required SLAs, and you want to list what disaster recovery policies are in place, and including the RPO and recovery time. So step 2, verify operating system and platform support. Azure supports a wide range of guest operating systems, including both Windows and, of course, Linux options. However, that support is not limitless. You need to check if the list of OS versions you recorded in your inventory are all supported. Consult the list of Azure's endorsed Linux distributions to see if your officially supported Linux distributions that qualify for the standard Azure Platform SLA. Consider whether you can migrate software that is hosted on legacy or unsupported operating systems to newer Azure-supported versions without requiring substantial changes or custom development. If not, then that application or service should be moved to an alternative migration approach list, which the remaining potential lift and shift candidates move to the next step. Step 3, verify the runtime frameworks and third-party library support. So we want to verify common frameworks like .NET and Java. Tied together with OS support, you need to really validate whether an application runtimes or even related activities used by these candidate application or services are supported on Azure. This includes making sure that the currently used versions of the common frameworks like .NET and Java will work. In addition to any third-party libraries used, also need to work properly on the target OS version. You must be diligent on this issue, as upgraded to the OS, frameworks, and libraries can introduce cascading dependency issues that can be very difficult to deal with in a migration process. As with OS support, if older frameworks and libraries cannot be upgraded to support Azure environment without substantial changes to your application or service, then move that application or service to the alternative migration list approach before moving the remaining lift and shift candidates on the next step. Step 4, identify any potential infrastructure requirements or challenges. After you determine that the guest application or service can operate as an Azure virtual machine, the next step is to identify any technical concerns with hosting resources on Azure. This stage can require in-depth research to compare Azure capabilities with your current on-premise infrastructure, ensuring that all features and requirements required for this candidate are available on Azure. If the infrastructure requirements of the candidate can't be moved on Azure without an acceptable amount of modification and cost, move the application or service to the alternative migration approach list. Each organization, application architecture, and data center can have a unique infrastructure. So this list of potential issues to research will be unique to each of your candidate applications or services. That said, many of the most common infrastructure challenges can be broken into the following broad categories: network connectivity and isolation requirements. For example, how do resources within your candidate application or server communicate with each other and the outside world? Is the candidate meant for internal use only? Will the users need to be accessed over public networks? What kind of routing and firewall capabilities do you need? The Azure Virtual Data Center provides, a comprehensive approach to maintaining your overall governance, security, and network design. And can you explain what kind of routing and firewall capabilities do you need? Can your existing Azure virtual networks and network virtual appliances support the needed capabilities? Step 5. Validate other criteria and create a preliminary list of candidates. At this point, you should have a high level confidence that the remaining list of applications or services on a technical level are good lift and shift candidates. However, from an operations perspective, less explicitly technical criteria can be just as important in deciding if a migration is justified. So let's talk about operations a little. If a candidate is successfully migrated to Azure, how much will your operation processes need to change? Well, here's some common concerns. How will your backup and recovery mechanisms need to change when resources are hosted in Azure? Will your disaster recovery planning need to be modified? Will your existing monitoring tools work in the new environment? And if not, how much will it be required to identify and implement an alternative approach? Will your existing high availability architecture translate to Azure? Will your existing DevOps tools and processes need to be modified? So again, a lot of questions around operational needs. What about the legal and regulatory requirements? Are there legal or regulatory compliance concerns related to your application or service, such as privacy laws or data retention requirements? As with any migration plan, you are likely to need to consult organization's legal compliance team to thoroughly vet the lift and shift process for your candidate application and services. And last but not least, costs. Ultimately, a migration is a business decision. And if the cost of moving to the cloud cannot be justified, there's no point moving forward. The initial migration involves one-time costs related to setting up your Azure environment and migrating applications and services. However, aside from these migration costs, you must understand the ongoing costs required to host your application or service. You should now have a good idea about the number and the type of resources you will need on Azure to migrate a candidate application or service. And then these should allow you to build cost estimates for the migration. To understand ongoing costs, review and verify any assumptions you may have about operations and related support tasks. Azure has extended capabilities to scale your application resource needs. With this information, you can generate quality cost estimates for hosting and maintaining your candidate applications or services. So finally, now that we've gotten all that information, let's choose the right deployment model. It's really important to choose the right model. Using the correct Azure virtual machine sizes, really help contain costs. You want to really select that correct deployment patterns for your workload. And again, using products like our product, like Stratosphere UX, you can really understand those workloads and those predictability on those workloads and how you can scale those workloads. So let's talk a little bit about the right deployment model. So in a physical data center, the initial cost, notwithstanding depreciation models, of purchasing and configuring hardware can be very large in comparison to ongoing operations expense. Your peak loads might be much higher than most operations, and some workloads might not need it only occasionally. However, you still need to purchase and operate all the server hardware necessary to handle these higher loads. On a cloud platform, for example, there is no hardware to purchase and no upfront cost to create a new virtual machine. You pay for compute, storage, and networking resources you actually use. Virtual machines that aren't needed for a specific time can be shut down to save on compute and networking costs. You still can start them back up when they are needed. You can spin up additional virtual machines during high traffic or special events like Black Friday or month-end processing. You can resize them down or up. Azure Cost Management can really help you optimize your spend in the cloud while maximizing your cloud potential. The lift and shift model moves your applications and services to the cloud with as little modification as necessary. However, you will save a lot of your ongoing costs if you properly understand your resource utilization and pick the best deployment model to use when you're migrating resources. So let's talk a little bit about that, using the correct Azure machine sizes. The first step to optimizing your Azure resource is to understand the capabilities of your existing hardware. Using the information to best secure Azure virtual machine to size that load. Larger virtual machines cost more to run, so make sure you set the right aside for that workload. Consider the age and utilization levels of your current hosting platform. Is it possible that the compute core on Azure is materially faster, requiring fewer cores with that current deployment? Make good use of any utilization data you have on existing hosts and virtual machines to identify performance requirements. Note the nominal and peak usage of each server and map these to the appropriate virtual machine sizes. For example, sizes for Windows virtual machines in Azure and then sizes for Linux virtual machines in Azure. Virtual machines can be easily resized, so after any deployment to Azure, continue to monitor and tune your usage assumptions to make sure you're using the correct virtual machine size, as loads change over time. Next, selecting your correct deployment patterns for your workload. The simplest way for an IaaS application or service in Azure is to create a fixed number of always-on virtual machines in sizes capable of handling your peak usage requirement. One of the key advantages of IaaS on Azure platform is the ability to scale your virtual machines as your needs change. You can reduce the cost by adding or removing additional virtual machine instances or by increasing the capabilities of an existing virtual machine. For each application or service that you're planning to migrate to Azure, review the following deployment patterns to see if you can use them to optimize resource utilization without requiring any significant change to the applications themselves. So you have a couple different ways you can go. You have horizontal scale out and in, where horizontal scaling involves spinning up additional virtual machines to handle increased demand on your application or service. When the demand declines, these additional virtual machines are spun back down to reduce the resource usage. The pattern is well suited for stateless applications such as web of a N-tier application, calculation services, or all other processes that handle independent transactions. Applications that are already make use of load balancers are really good candidates for this kind of pattern. Then another type of pattern is you have this vertical scale up and scale down. So vertical scale up and scale down really involves increasing the size of the virtual machine to handle the increased demands. When the demand decreases, the virtual machine is decreased. If the workload increases and are predictable, for example, based on a specific time of day, vertical scaling can be scaled to increase the virtual machine size during the peak of time. Scaling can also be set to happen dynamically based on resource usage. This pattern is suited for applications like monolithic database services, stateful applications, or applications that need to track events across transactions. If you scale between sizes, you do not need to restart the guest virtual machine. Any applications or services that need to use this pattern need to be able to tolerate this brief outage. So let's talk about another deployment model, scheduled on and off. So for any workloads that do not need to be running 24/7, the relevant virtual machines can be turned off when not needed. This can be done manually or managed by rules to schedule when the virtual machine is started or stopped. This is a particularly useful pattern for development and testing resources that may only need to be used occasionally, or for business applications that do not need to be run at all times, such as reporting services. And finally, in all of this, let's talk about workload considerations using containers. And we're going to lightly touch on this. So some applications really may be good applications for containerization. And when we talk about containerization, we're talking about containerization platforms like Docker or Kubernetes, which really allow you to consolidate your code in an easy to deploy package that operates in an isolated software environment within a larger host OS. This can provide a much more efficient way to run smaller applications that do not need resources of a dedicated virtual machines. And I can give you examples off the head is like WordPress is a containerized application that you could potentially run that doesn't need the dedicated resources of an entire virtual machine. Next steps. Many risks and concerns involved in a lift and shift migration are identified to those experienced by IT teams contemplating any data center migration. You will need to understand the full complexity of any systems you need to move, and you must accommodate the existing functionality in order to have a new environment seamlessly. Consider testing your approach to migration using Azure Migrate. So as you can see here, there's some great resources on the screen. You have the Azure Virtual Center Lift and Shift Guide, the also Azure Data Center, Azure Architecture Guide, and also the Network Perspective Guide. I want to thank everybody for joining us today. My name is Robert Corradini. You can actually reach Liquidware at Liquidware on Twitter and at NetWatch on Twitter. You can also find out a little bit more information about our products if you email at sales@liquidware.com, or you can actually check us out at liquidware.com. And finally, my blog is at netwatch.me, and if you want to read about my ramblings, feel free. Again, this is Robert Corradini, and I thank you and have a great day.